All right, in this lesson we are going to continue talking about equivalent expressions, and we're going to look at something called the distributive property, which allows us to create equivalent expressions just like the associative and the commutative properties did. So the do now is kind of an introduction to that, so let's go over those answers real quickly so you can turn to that page, please. Let's take a quick look at these answers. So define the area of this section, we would do 10 times 60, and the area of this section would be 10 times 5, or you could think of this as one big rectangle, and the width, let's say, is 10, and the length is 60 plus 5. That's why you could have either one of these. The distributive property has a lot to do with parentheses, so keep that in mind. Notice how these two are equivalent expressions. And then a little bit of translation into a situation where we're going to apply the distributive property. Note that we've done these translations before. It's the product of 10 and something, and that something is 60 plus 5, the sum of 60 plus 5, and that has to go in parentheses. All right, so let's do a little exercise. Actually, I think we're going to do the homework next, so take a look at those answers. Oh, never mind, there was no homework last night. So what I'd like you to do is pause the video and just do the problems in the top two boxes, okay? Just the top two boxes, and then come back and we're going to talk about that a little bit. All right, check out these answers. And notice I did order of operations, so I had to do what was in the parentheses first, and then I do the multiply. Here I had to do the two multiplies first, and then I do the addition. And I'm sure you noticed that the answers on the left were the same as the answers on the right, and maybe even made the connection that in the parentheses were the two numbers that I multiplied the outside number by. So we had the 5, the 3 and the 2, the 5 and the 3, the 5 and the 2, the 6 and the 1 and the 4, the 6 and the 1 and the 6 and the 4, and so on. This is the distributive property. It tells me that this is the same as multiplying the 5 times the 3 and the 5 times the 2. So basically I'm multiplying what's on the outside times everything that's on the inside, and I did that in every case here. All right, but let's take a look at the bottom box. So this one's a little trickier. I can't do here what I did up here, because now I have a variable. I can't add n plus 2. That is not 2n. They are not like terms that we discussed the last couple of days. You cannot add 2 and n because they are not like terms. So I kind of have to do what I did up here. So for example, I can write this as 5n plus 5 times 2. Or I can say 5n plus 10. And I'll do another one. I'm going to write this as 6n plus 6 times 4, or 6n plus 24. So I'd like you to pause the video and just finish up these last 4 for me, and we'll see how you did. All right, check out these answers. And the main thing I want to point out is we've created equivalent expressions. This expression here is equivalent to this expression here. And that's true for all of these. These are equivalent expressions, and we'll use something called the distributive property to do that. So let's turn to the next page and officially define the distributive property. So the official definition is the product of a number and a sum is equal to the sum of the individual products of the addends and the numbers. That's a pretty confusing statement, if you ask me. So let's just do a couple of examples. And just like we did on the other side, we're going to take the product of a number and a sum. And distributive property says that's equal to the individual products. So 2 times 3 plus 2 times 5. Let me do another example. 4 times 7 minus 1 is equal to 4 times 7 minus 4 times 1. So notice basically we call it the distributive property because 2 is distributed to the 3 and 2 is distributed to the 5 using multiplication. 4 is distributed to the 7 and 4 is distributed to the 1. The common mistake is that people just multiply the 2 times the first number. They forget to multiply it by the second. And you could have more than 2 things in your parentheses, and the 4 would have to be multiplied by all of them. All right, so an algebraic example, we saw that on the previous page as well, might be something like this. 3 times the sum of n plus 1. And of course, that's going to be 3n plus 3 times 1. Again, the 3 gets distributed to the n and distributed to the 1. So the key point here is that when you apply the distributive property, the coefficient next to the parentheses is distributed to each number inside the parentheses. So the coefficient outside the parentheses gets distributed to each piece inside the parentheses. Let's look at a couple of examples. So this first example says write 3 expressions that are equivalent to 4 times the sum of 5 plus 1. All right, let's see what we got here. So I can use the distributive property and say this is going to be equal to 4 times 5 plus 4 times 1. There's one expression. Then I could say this is the same as 20 plus 4. There's another expression. And then I could say this is equal to 24. There's my 3 expressions, all gotten from using the distributive property. All right, let's take a look at example 2. Can we rewrite 3 times the sum of n plus 2 using the distributive property? Well, of course we can, because we're going to distribute the 3 to the n, we're going to distribute the 3 to the 2, and that's going to give us 3n plus 3 times 2, which is also 3n plus 6. All right, so now I'm going to give you a chance to practice some of this, so if you could turn to the next page, please. I'd like you to pause the video and apply the distributive property to each one of these, and you can simplify it any way you want. You could get it down to 1 number or maybe 2, but we're just looking for an equivalent expression. And when you finish, restart the video and see how you did. All right, take a look at these answers. So for this one, I was able to continue to find equivalent expressions. I got all the way down to 50. For this one, I had to stop here because I can't combine 15y and 60. They are not like terms. Same thing here. Your coefficient can be another variable, but still the same property applies. I multiply the coefficient times everything on the inside, so that's y times 2 minus y times x. And I reordered that a little bit because we know that we can move things around in multiplication. And then this last one, 1/2 times the 20x is 10x, 1/2 times the 10 is 5, and again, I can't combine them anymore because they are not like terms. All right, go ahead to the next page and we'll do a few more practice problems. All right, go ahead and pause the video and work on these problems and then come back and see how you did. All right, check out these answers. These are pretty straightforward. This was similar to the one we did on the page before. I can have a fraction on the outside, so 1/4 times 4. You have to remember how to do that. For this one, they asked if this was equivalent to that, and the answer is no. You can only do distributive property. Looks like they tried to multiply the 5 times the n and the 5 times the 2, but 5 is added to this. Distributive property only works when the 5 is multiplied by the sum. So this number on the outside has to be right next to the parentheses. It can't have a plus there, then the distributive property does not apply. Then these, I just did the first step on these two. This one's pretty straightforward, so is this one. Here, the r is on the right-hand side, but it doesn't matter. We're still distributing the r to the n and the r to the 4. You could also write this as r times n plus 4, right? Because of the commutative property of multiplication, I can change the order. So you get the same thing either way. All right, I have one more page of practice problems. Please turn to that. All right, I want you to pause the video and work on these problems, and then when you finish that, come back and check your answers. All right, let's talk a little bit about these answers. So let's look at the word problem. During the summer, you make $80 per day plus whatever you make in commission. And that's extra money that you get for everything that you sell. So you get a flat rate of 80, and then the more you sell, the higher your commission is. So each day, it's 80 plus C. Now, if you make that much for 5 days, well, you're going to multiply this amount times 5. So we want 5 times that sum. So I'll use the distributive property to write 2 additional expressions for that. This one is using the distributive property kind of backwards. So one way to do it is to look at each one of these to see if I apply the distributive property to all of these, which one gives me that. And this one does, because I have 3 times 16 is 48, and then 3 times n gives me my 3n. Probably not this year, but maybe next year, or possibly not to algebra, you'll be working backwards, and given that, we're going to come up with that. But don't worry about that for the moment. All right, number 8, talking about a rectangle with sides of 8 and 5x minus 2. We want to represent the area of the triangle. Remember, area is length times width. So that's why I multiplied one side times the other side, and then I just distributed to get a different expression. So I did 8 times 5x to get 40x, did 8 times minus 2 to get minus 16. All right, so you can go ahead and start the homework if you want, and we're either going to have an exit card or another couple practice problems at the end of class. So let me know if you have any questions.